It is my absolute pleasure to introduce to you our next speaker, Don Wright. Don is a chief scientist at the Environmental Systems Research Institute, which you may know as ESRI, and is a professor of geology and oceanography at Oregon State University. Don has been elected to some of the most prestigious societies in the nation, including being inducted as a fellow of the American Association for the Advancement of Science, of the Geological Society of America, of the California Academy of Sciences, and more. Known as Deep Sea Dawn, she was also the first African-American woman to dive to the seafloor in Alvin. Dawn, we are so excited to have you with us today. Please take it away.
Thank you so much, Seth.
Looks great.
Sharing screens here. Okay, hopefully you're seeing that all right. Well, it's an absolute pleasure and honor to be with you today and with my colleagues here in this plenary panel. It's a huge honor to follow Bob Ballard. And Bob, thank you so much, because my PhD dissertation was based on Argo 2 data. But what I'd like to talk about today is geospatial as an accelerator of impact. And I'd like to talk a bit about a global geospatial framework that's emerging. It's very exciting. Hopefully it will take advantage of the internet, the underwater internet that Margaret mentioned. And it evolves and is supported by many organizations and communities. Everyone is seeking to share their data sets and services. This is dramatically extending the impact of geographic information systems, or GIS, but also other systems as well. And this is providing a spatial framework, we hope, toward helping ocean data achieve its full benefit. And why? Because spatial is special. It's a common language, as we know. It's a common language of points, lines, and areas, of course, but also photography and videography, other imagery, seismics, surfaces and volumes of ocean parameters. Geospatial lies at the heart of just about everything that we do and that matters to us in the ocean. Questions of where to best establish and enforce additional MPAs, especially in the high seas, where and how to sustainably feed a rapidly growing population with ocean-based protein, where to address hotspots of rapidly declining ocean oxygen or increasing ocean acidification, where to mitigate and adapt to a changing climate. All of these are inherently spatial issues. Now, one of the things that's beginning to happen also is that as we create and speak this common spatial language of maps and even 3D scenes that we can mash up and integrate dynamically, geospatial is starting to provide a proven framework in a virtuous circle, if you will, of measurement, analysis, modeling, of course, mapping and visualization, planning and evaluation, leading to decision-making, and most importantly, action in many use-inspired scientific disciplines, such as what you see on the screen. These disciplines are all quickly converging under this geospatial umbrella. They're all building integrated platforms that are bringing together and applying a collective geographic knowledge. People are sharing back and forth across these fields and their stakeholders as well, in academia, in industry, policy, even philanthropy. Now, to wit, I'm very happy to tell you about my colleagues who have already been funded on an NSF Convergence Accelerator Track A award. These are colleagues that we at ESRI are working with very closely. This is an exciting team that's led by geographers. And what they want to do is to integrate with smart oceans and to bring value add. This group is working on knowledge graphs, which usually power search engines and catalogs and apps. They're working on building a much more open web of structured scientific data in an open knowledge network with semantics and ontologies, vocabularies, standards, and so forth. They call themselves the Xray for places because the Xray is actually an emerging technology called geo-enrichment, which adds additional context to the data that you already have. It adds location-based context in terms of demographics, or it could be fishery stock assessments, parameters from climate models, any attribute that is missing that can now be added to empower your data. especially if it's empowered through artificial intelligence, geo-enrichment services, in an open cross-domain knowledge graph, such as what you see here as a prototype. So this is what this award is working on right now. They were just funded in September, and they're very excited about linking with smart oceans and empowering what we're talking about here. Beyond this group that we're working with at ESRI, ESRI is also working with a loosely connected network of organizations, such as what you see here, especially the organizations in yellow, the ocean-based organizations, and we're very, very excited about this. And a big part of this is empowering this community to create and share new approaches, new digital experiences for global sustainability, certainly for the UN Decade of the Ocean. So we're super excited about that. And biodiversity conservation, earth science modeling, forecasting, all of these fantastic goals. And a big part of this effort is our new Living Atlas Indicators of the Planet, which is sort of like a report card for the entire Earth. If you go to the URL on the screen, the indicators will fill up your entire browser window. And this is an effort that ESRI has partnered with Microsoft, National Geographic, and the UN Sustainable Development Solutions Network to compile, as of now, 18 pressing report cards about our planet, drawing upon real-time or near real-time data. In fact, behind the scenes of these indicators is a series of hosted Python notebooks, which touch the data in the cloud, along with AI algorithms that provide dynamic integration of the data from multiple sources, and then running consistent analytics on the fly. And as you can see, many of these all of these indicators are marked with the relevant SDG. And there's several of these SDGs that, of course, apply to our ocean, SDG 14. The Living Atlas, by the way, is one of the world's largest catalogs of geospatial data, information, and apps. We have about 200 million map requests made by 2 million users per day. And it's also being used by Microsoft as a content provider for the AI for Earth initiative and as a backbone for Microsoft's emerging planetary computer. Speaking of AI, there is a community that calls itself GEOAI, Geospatial Artificial Intelligence. And the greatest strides right now with GEOAI, with both vector and raster data, are in the areas seen here: classification, clustering, prediction. I just put a few of the functions that have been developed that are mature now for GEOAI. And some examples of research and studies is a recent prediction of seagrass distribution across the globe in a warming ocean. This was done in collaboration with NOAA, as well as another collaboration with NOAA, which was developing a 3D modeling of dissolved oxygen within the Monterey Bay. And what we're doing now is not only to do the study, but to create the resources to go along with the study, of course, the open data. And in this case, there is an open educational module that goes along with this project. You can get to it at the bottom of the screen, and it gives you the data, the algorithms, and the instructions so that you can follow along and learn. Something else that's really, really exciting is the concept of a digital twin, which is a virtual representation of an object, a process, or a system that bridges the gap, of course, between the physical and the digital world. But this is more than just a visualization. When it's implemented with IoT, such as what Margaret was talking about, the Internet of Things, and AI, it can accelerate our innovation. It can help us build consensus. It can test how components or systems function. This is really exciting now. It's happening for landscapes, and there's a big push now for seascapes. In fact, especially for ports. The Port of Rotterdam, for instance, is working with us at ESRI to create a digital twin of this port, especially so that it can accept autonomous self-sailing ships, container ships. So they're calling this a moonshot, not unlike what the European Union is planning right now in terms of a digital twin for the entire planet, so that they can simulate floods and droughts and fires. And their digital twin does, of course, include the oceans. Digital twins rely on sensor networks and the IoT, again, that Margaret mentioned. These are the things. But there's also a really important software backbone, and we're using IoT in many ways to get at the problem of IUU phishing. And here's an example here along with a dashboard that has been constructed for that. And there's also the idea of sharing the analytics behind this. So this is an R Studio session that's bridged with ArcGIS, where you can pull in appropriate feature services and image services, REST APIs, JSONs, geodatabases, and you can more fully analyze and interactively map the data, bridging those two platforms. And at ESRI, one of our longest standing ocean public-private partnerships to date is with the organizations and agencies that you see on the bottom of this slide. We have created a 3D base map of the entire ocean at a 1/4 degree horizontal scale and at 102 depth zones down to 5,000 meters. This is of the top physical parameters that control ocean ecology: temperature, salinity, dissolved oxygen, nitrate, phosphate, silicate. This is based on NOAA's authoritative World Ocean Atlas. It's been published in these outlets. It's also available as apps. And there are a number of use cases that are underway to deploy this 3D base map for ecological studies, or better yet, to build biological and biodiversity data into this fully 3D ecological marine units. So there's a lot more that I could talk about, but I need to stop now. And this is how you can get a hold of me. And if you'd like to grab these slides, plus a lot of supplementary notes that are associated with them, it's in the yellow text on the screen. Thank you so much.
Thank you, Dawn. That is really fantastic. So one thing that struck me, it's so great to see this amazing work you've been doing across discipline boundaries and across stakeholder collaborations. So a question for me is, in what way has this type of convergence accelerated impact? Or said in a different way, what do you think would have been obstacles without these collaborations?
Well, I think Bob has touched on that already in talking about how sometimes things are risky, but also when you've got a very risky scenario, and for a lot of us, collaborating with people outside of our comfort zone, collaborating with people who are in other disciplines, that's a risky proposition for a lot of us. We speak different languages, we use different tools, we collect data in different ways. But as the panel has already mentioned, that we can move so much faster and we can get such a fuller perspective if we are all in this together, as Peter says. So part of this is making sure that we can break down these barriers, and this is why this NSF program is so important, because it sort of forces the issue of us working across these disciplinary and these language boundaries in order to end up going faster in the end, because we're afraid that working across these boundaries is going to slow us down, and we don't realize that it's actually a way to help us move faster.
Thank you very much. It's a pleasure to have you speak.
Thank you.